Hi viewers, welcome to LMO Solution. Today we are going to see about fractional order PA controlled connected PV system, and also we are going to compare with the PA controlled connected PV system. So here we are going to use the fractional order PA controller, the voltage control element block, right? So here we are going to use that fractional order PA controller, and then we are going to check the response of the system, and also we are going to compare with the PA controlled grid connected PV system. So first I'm going to explain about the PV system. So here we have the PV. So the single panel have to 13 watts. Okay. And then voltage at maximum power point is 29 volt, and then current at maximum power point is 7.35 amps. And here we are having 10 series model, and then 5 parallel strings. Here you can check the maximum power of the VRA for the different irradiation condition. So here you can see that the maximum power is around 10.66 kilowatts up to 1000 watts per meter square. And for 500 watts per meter square, the maximum power around 5399. And then here you can see that the maximum power at 100 watts per meter square. Okay. The maximum power is around 10.66 kilowatt at 1000 watts per meter square, and then at 25 degrees Celsius. Okay. And here we are using boost converter, right? So because we need to maintain voltage, here is 700 volt, right? And then we need to boost up the voltage from this point, right? So here you can say that the single panel voltage 29, and then we're using 10 panel in series, so 10 into 29, so it's 290 volt. So the 290 volt when we step up to 700 volt. Okay. And also this boost converter can be controlled by means of MBPT algorithm. So this MBPT algorithm. So here we are using the P and MBPT. Okay. So P and MBPT, the P and MBPT when we receive two inputs, voltage and current, and then we are getting reference voltage here. It's going to be compared with the actual P voltage and going to be processed by a PA controller, and then when we compare with the setup waveform, so it will generate the pulse. So this pulse is going to be controlled this the IGBT of the boost converter, not to extract the maximum power from the PV panel. And then here we have three-phase inverter, and then this is LCL filter, and here we have three-phase voltage source. The rating is 400 volt and 50 hertz. Okay. Here we are going to control this inverter by means of uh, feed forward DQ control, right? So for that we have to use here we have to use voltage controller here. That means we need to measure the voltage of the DC link. So this is a DC link. Okay, you have to measure the DC link voltage. So the DC link voltage will be compared with the reference voltage. So we are going to use reference voltage here is 700 volt. Okay, and it going to be processed by a fractional PID controller. So this fractional PID controller. Okay, so here we are using KP 0.1 K3 and lambda is equal to 1.5, and KD we are using 0.1, here we are using zero point 0.5. So here you can say that this is equation for the fractional adder PA controller. Okay, and then it will provide ID reference. So this ID going to be combined with the actual ID. So here we are using that PLL and power transformation. Okay, clock and the power transformation, you have to generate BDDQ, IDIQ, and that we have to generate omega T. Okay, and this ID, right? So the ID reference going to be compared with the actual current of the inverter, right? And then going to be processed by API controller, and then here you are going to apply that the feed forward deep coupling concept. Okay, and finally we are generating the control voltage in the form of DHS. And also here you are making that the IP reference is 0 because we are generating sending only a real power, not reactive power. So then say you are making IQ reference equal to 0, and then going to be compared with the IQ of the inverter, right? And then it's going to be process API controller. So here we are applying that the feed forward compensation control, and then it will be generate the control voltage in the form of K axis. So next we have to convert this DQ0 into ADC by using inverse power transformation, and then I'm going to be processed here it will generate. Okay, so it will generate the pulse for this uh, this three phase voltage source inverter, and it going to control the current, that means current plus well as the real power flow from the PV invert PV to the grid. Okay. So here I'm going to make the condition, that means for every 1 second I'm going to vary the irradiation. So initially I'm going to make irradiation equal to 400 and then 800 and then 600. Okay. So and I'm going to then we are going to see the results of the and the PV power. Here we are going to see the result of, and so this is PV power, and then we are going to see the result of grid voltage, grid current, and this being voltage, and then we are going to see about ID IP reference. Okay, and also you have to check the THT of the grid current. Okay, infrared or inverter current. Okay, because whatever generating power from the PV is directly given to the grid, so we can measure the THT of the grid current or the inverter current. Okay, so it will be having same value. So now I'm going to create this model. So initially the irradiation maintained at the 400, right? And then after that it changed to 800, and then it going to be changed to 600, right? So before we need to check that the maximum power for the different condition. So here I'm going to make the irradiation equal to 400, and then 800, and then 600, and then set the response, and then you have to see here is peak power. For peak power for 800, right, is 8589. Okay, 8589 on 7. So peak power for 800 watts per meter square is 8589, and for 400, for 600, right? For 600 is 6475, and then for 400 is 4313. Okay, so this is theoretical, the maximum power point for that different irradiation condition. So we need to check this detail, the output response from PV power. So here you can see that you have to use this scale option. So here you can see that we are getting around 4307, right? So theoretically the value is 43. Theoretical value is 4313. So but we are getting around 4307. So next you have to check this for 800, right? So for 800, that so theoretical value is 8589. Okay. So you can see that what actually you are getting. So 8589. So here we are getting around 8570. Okay. So almost it extracting the maximum power from the PV panel. And then here you can see that this is the grid voltage. Grid voltage is maintained at 230 volt RMS up to face, and then this is, you can say this is a grid current. Okay, so for so here you can see that for 400 watts per meter square, right? Like grid current around the peak current around 10 amps. Okay, and for 800 watts per meter square, the peak current around is around 16 or 17 amps. Okay. Now we can see that the radiation changed to 600, and then we check that the peak power of filter PV power at 600 watt per meter square. So for theoretical value is around 6475. 6475. Here we are getting 6468. 6468 watts. Okay. So here also we are getting maximum power from the B panel, and also you are going to check the current of grid current, right? Grid current value during that time 600 watts per meter square. So this is around it's needing around 12 amps per peak. Okay. And then here we are seeing about IDIQ. So here you can see that the variation of IDIQ with respect to change in irradiation condition. So initially for 400, you can see that this variation of ID value is around 10 amps, 10 to around 10 amps. And then here you can see that for ID value during 800 watts per meter square is around uh, 16 or 17 amps. But for 600 watts per meter square is around 14 amps, 14 or 13 amps. And here you can say IQ value is maintained 0. So what's the meaning? So we are sending only real power to the plate. Okay, we are not sending any reactive power. Okay, so this is a results of that fractional order PI controlled well connected PV system. So let's just check the TST of the system. Okay, so here I'm going to take this one. That means we store the results, right? This result as name of scope data and data set, right? So that data will be stored in the workspace as out. So here you can see that scope data. So just to track and paste, put paste here and then enter. So you will see that the data set here. So next to go to this simmering block and then open this Power GUI, right? And then go to FFT. So now we can select IABC and then you go to change to 50 hertz and then change to same as the maximum frequency. So now I'm going to check TST. So now THT here you can see that the THT around 0.84 percentage. Okay. So I'm going to change the time value 1.5 and then check the THT. So here you can see the THT around 0.45 percentage and then I'm going to change the time to 2.5 and then check the TST. So TST is around 0.4%, 46 percentage only. Okay. So in this method, right, we extract the maximum power, maximum power from the PV, and also the TST of the grid and inverter current is around that means less than 1% only by using this fractional order PA controller connected PV system. So next we have to discuss about the same system, but in this system we are going to use only PA controller in the voltage control element. Okay, once again. So here this model. So here I'm going to open that model. So here you can see the same system, but here we are using the PA controller, right? PA controller. And then I have to use the same condition, whatever condition we followed for the fraction order and controlled connected PA system. So same control and the operating system we have to make here. So here we have to compare the same system result with the PA controlled grid connected PV system. So first you have to check the PV power. So where I'm going to use this scale. So for 400 watts per meter square, the maximum power we are getting is, we'll check that one, right? Here we are checking 4292, right? But in case of fraction at a P control, you are getting 4307. But here we are getting only 4292 watts. Okay. And also here you can see that the IQ value is not settled to 0, right? It having some value. That means that means grid current, right? Grid current or inverter current have some harmonics. Okay. So it sends some reactive power also. Okay, so that's why we are getting this IQ having some value. So let me check that current of the grid. Okay, so here you can see the current of the grid. So here is a grid current, right, during that 400 watt per meter square. Next we have to check that means when changing irradiation from 400 watt per meter square to 800 watts per meter square, we have to check the PV power. So actual theoretical value is 8589. Okay, so we will check that. So here we are getting 8571, but in case of fractional order, I think is we are getting 8579. I think so, right? So here also you can see that. So here we can see that variation of the grid current. Okay, but that grid current having some hormone side because having a IQ is not settling to 0 till now. Okay. So this variation of ID and IQ. Okay. So after 2 seconds, right, irradiation change from 800 watts per meter square to 600 watts per meter square. Let me wait and check the results. So this is a variation of grid voltage. So here the grid voltage is maintained at 230 volt. background, right? So now you can see that now only the die key is reached to 0. Okay, so it will take more than it will take around 2 seconds to reach 0. Okay, as 5 is 0 only, that we can we only sending real power to the group. Okay, when IQ is having some value, would it draw some reactive power. So that is some, that mean the THT of the group current will be increased to do this reactive power. Okay, so now we can see that we are extracting the maximum power around 85, sorry, 6463, right? Here you can see that we will extract the maximum power is 6463, but actual theoretical value is 6475 watts. And also you can see the grid current here. So this is a grid current. So next we have to check the THT of the system with the PA controlled connected PA system. So for that I'm going to open this out and then that means and drag and put in the command window. So and then I'm going to open GST F50 analysis and press, and then once again, so drag and place in the command window, enter and go to F50 analysis, then click IABC and then do same as the frequency and display. So here you can see that we are getting 2.9%, but when we are using fractional controller, right? So here you can say 3.95. So for 2.5 seconds, we are getting around 4%, right? So the THT around more than 2 to 5%, right? But in case of fraction order controller, we are getting only the TH less than 1%. So when comparing the results, right, that result of a fraction order PA controller with the conventional PA controllers, fraction order PA controlled liquid connected PA system will provide the better results than the PA controlled liquid connected PV system. So this is the working of this model. So thanks for watching our videos, and kindly subscribe to the channel and also click bell icon for notification about upcoming videos. Thank you. Thank you so much. Bye bye.